Welcome to lecture series in physics. In this series, we are discussing about gravitation and its related parameters. In this session, we are going to discuss variation of G with the depth, and we are going to discuss about the theory, construction, working principle of compound pendulum. Then we are going to discuss about equivalent simple pendulum, and we will be doing some problems related on gravitation. So, let us now turn our attention to discuss variation of G with the depth. So, let G and G dash be the values of acceleration due to gravity at P and Q respectively. So, this is the point P, this is the point P, and this is the point Q. So, let at P the acceleration due to gravity be G, and let at Q the acceleration due to gravity be G dash. So, we are interested to find out what is the variation of acceleration due to gravity with the depth. So, let us consider at P the whole mass of the earth attracts the body, and H is the at a height h. So, at P the whole mass of the earth attracts the body. Therefore, you apply Newton's law of gravitation for this point. So, when you apply Newton's law of gravitation, I get that is F is equal to, it is G m by r squared. So, therefore, the formula for force is mg. Therefore, mg is equal to G m by r squared, where G is the gravitational constant and r is the radius. So, the value of gravitation constant is 6.67 into 10 power minus 11 nm squared kg power minus 2. So, here small m is the mass of the body, small m is the mass of the body, and capital M is the mass of the earth, and capital R is the radius of the earth. So, at this point Q, so in this point Q, what happened? The body is attracted by a mass, by the earth of radius, it is h. Therefore, this is r. Therefore, the total value will be r minus h. Therefore, mg is equal to G m dash m by r squared, and since mass is equal to, it is volume into density, then I can write. So, the volume of a sphere is 4 by 3 pi r cube rho. So, you apply this equation over here, therefore, mass is 4 by 3 pi r cube rho, and for m dash it is, if it is h here, then m dash is equal to 4 by 3 r minus h the whole cube into rho. Therefore, where rho is the mean density of the earth. So, you divide these two equations. This is the second equation and this is the first equation. So, divide these two equations, and when dividing this equation we get G dash by G is equal to m dash by m into r squared by r minus h the whole squared, and when you simplify it further, G dash by G turns out to be 1 minus h by r. Therefore, G dash is equal to G into 1 minus h by r. So, when you consider this expression G dash is equal to G into 1 minus h by r, we can see from the expression that the acceleration due to gravity decreases with the increase of depth. So, let us now discuss about compound pendulum. So, what is a compound pendulum? That is any rigid body capable of oscillating freely about a horizontal axis passing through it is a compound pendulum. So, let us now try to find out the period of oscillation of a compound pendulum. So, basically how a compound pendulum will look like? A compound pendulum is nothing but it is a rectangular bar, say of 1 meter in length and 3 centimeter in width, where there are a number of holes grooved at the center. So, this is the schematic diagram of a compound pendulum, and this compound pendulum is hung from a wall, and for each and every hole there is an equal distance of 5 centimeters you say. Therefore, the distance 5 centimeters and this is 10, this is 15. Likewise, there are 20 holes in the compound pendulum, and for each hole the distance graduation is 5, 10, 15 and so on. So, from this compound pendulum we can find out the time period and acceleration due to gravity of a compound pendulum. So, let us consider O be the point of suspension and G is the center of mass. This is the schematic diagram of a compound pendulum. So, this is how the compound pendulum looks like. So, the center point is O, and we can draw a line over here, straight line, and there is a oval line here, and this is a line. So, this is G dash and this is G, and the weight over here is mg, and this is the center point O. So, you from this diagram you consider, let O be the point of suspension and G is the center of mass. So, in the equilibrium position OG is vertical, and you can say OG into OH. Suppose the body is given a small angular displacement, say about this is the angular displacement theta, and let go, and therefore, what will happen, the center of the mass is displaced by a factor G dash. The body oscillates about the equilibrium position, and also it can be shown that the motion is a simple harmonic motion. So, basically what is a simple harmonic motion? That is, a simple harmonic motion is nothing but it is a particle is said to execute a simple harmonic motion if its acceleration is directly proportional to the displacement and directed opposite to that of displacement, or you can say A is directly proportional to x and A is directly proportional to minus x. Therefore, A is equal to minus kx, or A plus kx is equal to 0, or we can say d squared x by dt squared plus omega squared x is equal to 0. So, this is the second order differential equation for a simple harmonic motion, where d squared x by dt squared denotes acceleration and omega is the angular velocity and x is the displacement. Therefore, this compound pendulum executes a type of motion known as a simple harmonic motion. So, let us consider m is the mass of the pendulum. Therefore, the restoring couple due to gravity is mgh sin theta, and the couple is also equal to I into d squared theta by r squared, where I is the moment of inertia of the body about the axis of rotation and d squared theta by d r squared is the angular acceleration. Therefore, the equation of a motion of a body, that is I into d squared theta by dt squared, that is we have an expression tau is equal to I into alpha, and where I is the inertia and alpha is called the angular acceleration, and if theta is the angular displacement, then I can say d theta by dt is the angular velocity, and d squared theta by dt squared is the angular acceleration. Therefore, alpha is equal to, it is d squared theta by dt squared. So, therefore, substituting in this expression I into alpha, I into d squared theta by dt squared is equal to mgh sin theta, and therefore, from this you calculate what is d squared theta by dt squared. Therefore, d squared theta by dt squared in this expression, it gives rise to, it is mgh divided by I into sin theta. So, therefore, or it is, there should be a negative sign here. Therefore, d squared theta by dt squared is equal to minus mgh by sin theta, or that is equal to minus mgh by I. Since sin theta is very small, we can approximate sin theta to be to theta. Therefore, when you substitute in this expression, I get d squared theta by dt squared is equal to minus mgh by I into theta. So, now mgh by I is a constant quantity, Therefore, angular acceleration is nothing but d squared theta by dr squared is proportional to the angular displacement theta, and the motion of the body is simple harmonic. Therefore, the time period t is nothing but 2 pi into root of displacement by acceleration, that is equal to 2 pi root of I by mgh, or it is 2 pi root of, for angular displacement it is theta, and for acceleration it is mgh by I into theta. So, you apply a theorem known as parallel axis theorem. According to the parallel axis theorem, I can say I is equal to ICM plus mh squared, and I is equal to mk squared plus mh squared, where k is the radius of gyration of the body about an axis passing through the compound pendulum, and therefore, since I is equal to m into k squared plus h squared, then substituting in the time period I get t is equal to 2 pi root of m, 2 pi into m root of k squared minus h squared by mgh, or t is equal to 2 pi into root of k squared minus h squared by gh. And let us now say a few words about equivalent simple pendulum. So, a simple pendulum which oscillates with the same period as the compound pendulum is called the equivalent simple pendulum, or in other words, it is a form of compound pendulum where a simple pendulum oscillates with the same period. So, in the case of simple pendulum of length L, the period, then the time period is given by 2 pi root of L by G. So, you compare the expressions, you compare this expression and this expression. When you compare this, we can have L is equal to k squared plus h squared by I, that is equal to h plus k squared by h. Therefore, then the point C is called the center of oscillation as shown in the diagram. So, this point C is called the center of oscillation. To show that the center of suspension and the center of oscillation are interchangeable, then O is the center of suspension here. Here this O is the center of suspension and C is the center of oscillation. So, O is the center of suspension and C is the center of oscillation. So, therefore, I can write OG is equal to L, then OC is equal to L plus L is equal to k squared plus h squared by I. Therefore, simplifying we get k squared equal to OG into CG. Therefore, the symmetry of the expression k squared is equal to OG into CG shows that if a body is suspended about a parallel axis through C and O, that would be the center of oscillation. So, from this we can conclude that the center of oscillation and suspension, from this we can conclude that the center of oscillation and suspension are interchangeable. So, we will find out what is the minimum time of oscillation for a compound pendulum. So, the minimum time of oscillation for a compound pendulum is given by capital T, that is equal to 2 pi into root of k squared minus h squared by gh. Therefore, so in order to have a t a minimum value, you should differentiate this equation and you should substitute it to be 0. Therefore, when you substitute d by dh into k squared plus h squared by gh is equal to 0, and when you do all this simplification, we get I minus k squared by h squared is equal to 0, or k is equal to h. Therefore, the period is a minimum when the radius of gyration about a parallel axis through the center mass of the body is equal to the depth of the centimeter below the point of suspension. And this is the schematic diagram for a compound pendulum. So, this compound pendulum is nothing but it has a uniform metal bar, and it is the length of the metal bar is approximately 1 meter long, and it has a number of holes drilled at regular intervals side of the center of mass G. This is the center of mass G. Normally, the number of holes are drilled at regular intervals at 5 centimeters each. The horizontal knife edge is passed through the hole near the end A, and the period of oscillation is determined and the distance of the knife edge from the end A is measured. So, the experiment is repeated and the bar is made to oscillate about the knife edge placed successively in different holes from A to B. Therefore, in each case the period of the knife edge from the same end A are noticed. So, you draw a graph by taking period along the y axis and the distance from A on the x axis, and you get two graphs like this. So, two curves are shown, and how the two curves will be there is like this. So, this is a schematic representation of two curves, and a horizontal line PQRS is drawn. So, along this a line PQ, this is P, this is Q, this is R, and this is S. So, an horizontal line PQRS is drawn cutting both the Q's at the points. Let PR is equal to QS is equal to L, the length of the simple pendulum. Therefore, if T is the time period given by, then we can write 2 pi root of L by G, or G is equal to 4 pi squared into L by T squared. So, knowing L and T, we can calculate the value of G at a given place. So, this is the theory of a compound pendulum and equivalent simple pendulum. So, after seeing the discussions on compound pendulum and equivalent simple pendulum, we will solve a problem. I will read out the problem. A compound pendulum is formed by suspending a heavy ring of radius 4.905 meters. And what is the length of the string for the minimum period? Calculate this period. So, this is the problem. Since the ring is large and heavy, the weight of the string may be neglected, so that the center of mass of the compound pendulum will be the same as that of the ring, that is the center of the ring. Let small m and capital R be the mass and radius of the ring. So, if the ring oscillates in a own plane, then we can have the moment of inertia of the ring. The moment of inertia of the ring about an axis passing through the center and perpendicular to the plane is nothing but, that is the moment of inertia is given as I. So, that is I is equal to m r squared. So, that is equal to m k squared, and where k is the radius of gyration of the ring about an axis through the center and perpendicular to its plane. So, therefore, for the condition k is equal to r. Therefore, the period is minimum when k is equal to h, where h is the distance of the point of suspension from the center of mass of the ring. This gives h is equal to r. So, therefore, we can have the time period as, or we can say k is equal to r. So, therefore, the period is minimum when k is equal to h, and therefore, we have the time period t is equal to 2 pi, it is root of k squared plus h squared by g h, where t is minimum when k is equal to h. So, we will calculate what is t minimum. Therefore, T minimum is equal to, it is 2 pi root of k squared plus h is equal to k. We have k squared plus k squared by kg. So, that is equal to 2 pi root of 2k by g. So, therefore, we can rewrite this expression as it is 2 pi root of 2k by g. So, that is equal to 2 pi, it is root of, it is 2r by 2r by g, since k is equal to r. So, here we have the value of r is given as, it is 4.905 meter and g is 9.8 ms power minus 2, and when you substitute in this T minimum, that is T minimum is equal to, it is 2 pi root of 2 into 4.905 divided by 9.81. So, therefore, what is the value of T minimum? The value of T minimum is, it is 6.282 second. So, this is the final answer for this problem, and we will discuss the another problem. I will read out this problem. A uniform rod of length 1.2 meter oscillates about an horizontal axis of the rotation passing through one end. Find the period of oscillation and also find the positions of the other points about which the period is same, and also you calculate the minimum period possible and the position of the axis of rotation for obtaining the minimum period. So, first look into this problem. We will find out what are the data are given. So, the data is there is a uniform rod of length 1.2 meter. So, the length of uniform rod is 1.2 meter, and what it does, it oscillates about the horizontal axis of rotation, and from this data you should find what is the period of oscillation, and also you should find out the positions of the other points about which the period is same. And the third question is, you also should calculate the minimum period and the position of the axis of rotation for obtaining the minimum period. So, in order to solve this problem, we have this value, that is k squared is equal to, it is L squared by 12. So, the rod of length is how much? It is 1.2 meter. So, therefore, it is 1.2 by 12, and h value is, it is given, it is 1 by, or it is L by 2. So, that is given as 0.6 meter. Then we should calculate what is the T. So, the formula for T is 2 pi, it is root of k squared plus h squared by g h. So, you substitute in this formula. So, we have T is equal to 2 pi root of k squared plus h squared by g h. So, therefore, that is equal to 2 pi, you substitute the values, 2 pi, it is 1.2 the whole squared divided by 12 plus 0.6 the whole squared divided by 9.8 into 0.6 into 0.6. So, when you simplify this, we will get the answer as 1.794 second, and the position of other points which the period is same, therefore, the number 1 is the other end of the rod. The other end of the rod, and the second is the point distance. It is k squared by h, that is equal to 1.2 the whole squared by 12 divided by 0.6. So, that is equal to 0.2 meter from the center on either side. So, the distance is 0.2 meter from the center on either side. So, therefore, we will calculate what is the time period minimum. Therefore, the time period minimum is, it is 2 pi root of 2 k by g, that is equal to 2 pi. So, you substitute the value 2 into, it is 1.2 divided by root 12, close the bracket, by 2 pi 2 k by g is 9.8. You substitute, and when you substitute, the value is 1.671 seconds. Therefore, the position of the axis of rotation for obtaining the minimum period is k. So, that is equal to 1.2 divided by root 12, and when you simplify, what is 1.2 divided by root 12? It is 0.346 meter from the center of mass of rod, from the center of mass of rod. Let us now summarize what we have learned so far in this session. In this session, we are discussing about gravitation. On gravitation, we discussed about the theory, construction and working principle of a compound pendulum, and also the equivalent simple pendulum. And based on the two pendulums, we find that the acceleration due to gravity performed by the compound pendulum and the equivalent simple pendulum are one and the same. And after discussing this compound pendulum and equivalent simple pendulum, we solved some problems pertaining to gravitation. Thank you.